Before the slides come up, I guess I can just talk a little bit about, because what I'm going to walk you through is a study that we ran talking about the difference between walking versus wheeling in a wheelchair in VR. And a little bit of the background that's not really in the slides is where that idea came from. Other than just being accessible, one of the things that we were thinking about was what is a better interface for virtual reality? And one of the realizations is that we have this immersive new medium that has all of these tremendous tools, different ways of seeing or experiencing the world. But essentially, it's been designed on the platform of other mediums trying to do what they do. And one of the things we will see is some of the ways that that legacy impacts the possibilities that we envision for this. Yeah, so here we go. So I just want to talk a little bit. Oh, there we go. I just want to talk a little bit about the difference between the wheeled experience versus the walk-in experience in VR. What a concrete interface for VR could look like. I'm going to go. Is this okay? There we go. I just want to add a couple disclaimers. Okay, oops, there we go. Well, it's fine. First, no simulation of the wheeled experience is going to encapsulate what it means to be someone who lives and uses a wheelchair on a daily basis. So I just want to make a point that where we talk about empathy and the ability of the interface or the idea of an interface to provide insights, that's related to the physical experience of navigating spaces. It is not to say that it encapsulates the experience of being in a wheelchair. I also want to say and make it clear that I do not represent the disabled community and I don't speak for them. I'm presenting information about virtual navigation interface affordances, which could, but do not inherently benefit that community. Nothing for us without us is something that we strongly believe in. And so I just want to make sure it's clear that I'm not here trying to represent a community. I'm going to play this video because it exists and it does a better job more quickly of giving a little bit of the background on how we got started with the study. So I'm just going to hit play.
The concrete interface is a novel type of interface for virtual reality. It's a way for someone to have a virtual or interactive experience using their wheelchair.
VR, at least literature tells us, to really get the fullest of VR is you need to be able to walk. You need to be able to walk around. We call it one-to-one walking is the non plus ultra. We think that might not be the case.
Universal design tells us that a better design is a design that works for more people.
We are doing a study comparing different forms of locomotion in VR. One-to-one walking, which is the gold standard within the industry. One-to-one wheelchair use, which probably compares to one-to-one walking. We don't know that yet. And then using a joystick or the wheelchair on our interface.
So we're really lucky that we've been able to use the HP Omnicept Edition headset. It has sensors that detect your heart rate, as well as eye tracking that measure your pupillometry, which is how much your pupils are constricting and dilating. The information from these sensors is fed into a machine learning algorithm that HP developed and tested. And together, those two sources of information are combined and produce an output called cognitive load.
Cognitive load is a very important indicator for performance. So you're really trying to find the Goldilocks zone where people can perform the best, not underloaded, not overloaded, but in the right place. Cognitive load provides that kind of information so that we can create adaptive information for training, for education.
So when I met the leaders or the principal investigators of the Blended Reality Lab, I realized that the Blended Reality Lab has a lot in common with the Sports Equity Lab in that both of us are interested in questioning the assumptions that inherently exclude marginalized segments of the population, i.e., those with disabilities, those who are excluded from society for whatever reason. A common misconception is that most of us can't relate to disability, but the definition of disability is a physical or mental condition that significantly limits one or more major life activity. So whether that condition is temporary or permanent, we have all experienced or will all experience a disabling process of some kind due to an accident, a diagnosis, or just the normal aging process. Disability is additionally conceptualized as the dynamic interplay between personal factors, health conditions, and environmental factors. So those three.
When I first met Yetza, she was really trying to come up with a way to make an experience that reduced the stigma that we have for people who are disabled. She wanted to show how powerful and amazing para-athletes are. And what I realized is, while talking with her about how effective a wheelchair-based interface for VR could be, I realized it might even be a better interface than the ones that we're used to.
The idea is to just place the wheelchair on a roller system where you can roll forward, you will feel resistance, you will feel the vibrations of the wheels actually moving. You have this immersive feeling that something is happening.
You're actually learning physically the embodied experience of being in a chair and wheeling your way through the uncharted territories. A maze, maybe a city street, maybe a new dormitory that you happen to be part of. And so you're physically learning through that embodied experience what another person who is seated, potentially involuntarily, learns as well. You're also learning how to create solutions for mobility that you wouldn't have thought about before because you typically use your 2 feet to walk around. The limitlessness of the virtual space enables access for all the segments of the population that we care about at the Sports Equity Lab and that blended reality cares about too.
So sorry for the abrupt ending. I tried to cut it as much as I could. But just to say that that was the idea for the project and how we got started. We were trying to build an actual, a full interface. And one of the things that we wanted to do was test and make sure that if we were making an interface, before we went too far along, we wanted to confirm this idea that it could be a good experience, an equitable experience. This is the team that was working on the project. At the time, I was the principal investigator of the blended reality grant, and we had a lab at the Center for Collaborative Arts and Media at Yale University. These are all the different people that I worked with: Yetza Tuakli Wasanu, Johanna Sieber, James Nickel, Veronica Wieser, and Bryce Bai. It was a lot of people coming together to work on this. We also consulted with and worked with Roy Cooper from the Human Engineering Research Labs at Pitt, and the Sports Equity Lab, of course, which Yetza founded. So what we really wanted to do was we wanted to say, a lot of the time when we're thinking about what would be good or what would be bad, we operate on a basis of assumptions. And what we wanted to do was empirically prove that if you had a accurate simulation of being in a wheelchair, that the experience in VR was equitable to the traditionally understood gold standard of one-to-one walking. We used a number of methods. The traditional way that VR experiences are tested are with self-report measures. So that's checking for motion sickness, sense of presence, usability, playfulness, etc. But we also wanted to incorporate the other behavioral measures, like as you'll see, I'll show you, we used a spatial updating task. So not only seeing if the experience was good, but making sure that people had a meaningful and functional experience through that interface. And we were also using some biometric measures, which I'll talk about in a little bit. The basic idea of the behavioral measure was a spatial updating task, and I'll show you here what it looked like. Basically, there were a set of randomized mazes that we had set up, and we had people acclimate themselves to the interface, and then we randomized which of the mazes they would be navigating through. It's worth mentioning that all of the participants in the study were primarily ambulant. That was because in order to do the study, we needed to have the same individual compare the walking to the wheeling experience. So it was for those reasons that we made that choice. So basically, the person would start in one place. They would see a destination arise, and then a maze would appear that they would have to navigate through. After they navigated through the maze, they would spin around, and they would have to determine where they had started in the maze. So they would, point where they thought they had begun. Then they would measure how confident they were. And then we would determine how far off they actually were. So the idea was to figure out when people are navigating virtual spaces in wheelchairs, not only do they enjoy the experience, but are they able to gain a spatial understanding or perception of the environment that they're navigating? And then, of course, we ran the exact same study. It would repeat, but just to show with them in the walking condition. So it was really comparing individuals navigating the space in both conditions and then seeing if they were better in one versus the other. One of the things that's really notable here is you would expect that people who primarily don't use wheelchairs would prefer the walking-based experience. It's kind of an assumption that we might have. But what we found is actually that that's not necessarily the case. The significance that people had in terms of their ability to determine where they had begun or where they started was actually the same for people in all conditions, or roughly the same. I think there's like a 1 degree of difference or 1.5. What that means is that the people using the wheelchair to navigate the space, even though that was an unfamiliar interface for them, did just as good as they did when they were walking normally. We also use self-report measures, right? The self-report measures are the kinds of things that you normally do when you're, testing a study to see if a VR experience is good. We used 4 different questionnaires. I'm not going to go through each of them for reasons of time, but I'm happy to share these slides for anybody that wants to follow up. But if you look here at the results, these are the results of all the different ones. I know the numbers are kind of like difficult to take in at a glance, but I wanted to include this chart so you can kind of see for one of them that the differences are pretty minimal. There were some differences, but not many. And again, the sort of key insight here is that people who do not habitually use wheelchairs found the experience to be just as comfortable, just as relatable. They didn't have more confusion. They were not unable to tell how they had gotten where they had gone. They had exactly the same sense of presence and the understanding of the virtual experience that they had had. Finally, the biometric measures. We did collect the data on the cognitive load that was mentioned in the study. What we found was that it was, again, fairly similar. The wheeled condition maybe was a little bit lower, but we actually didn't include that in the paper that we published. That's something I passed over very quickly. The paper for this, I'll just go back real quick. Again, and I know that it's hard to take all this stuff. Oh, geez, I don't want to go through all this. This is like a, the link to the paper that was published in the journal Virtual Reality is here in the center of the page. And again, I can share these slides with anybody that wants them afterwards. So you can go, guys can go and see that. The data that we collected is also all in its raw form available online as well, including the cognitive load information. The reason we didn't include it in the paper was honestly because as we're learning about a lot of issues, oh geez. All right, I'm gonna jump on. Basically cognitive load, the issue is I talk too much. It's like a problem. Just ask my wife, it's like a disaster. Oh my God, okay. I didn't even get to the fun part. Okay, I'm stop here. Real quick, here's what I'm gonna say. The reason we didn't use the cognitive load information in the actual paper was because we just weren't able to verify the way that that algorithm was designed and built. And what we felt was an important paper. We didn't want to put anything in that we couldn't stand behind 100%. But the data is still publicly available and accessible. If it shows walking versus wheeling, they're the same, what's the point? It's because it shows that a wheeling-based experience is not any worse than a walking one. What that actually means is that we can create accessible interfaces that rival or exceed what is currently considered the gold standard. When we think about one-to-one walking as considered the gold standard for locomotion, we take this for granted. And I just want to show you some of the interfaces that have been built. I want you to think about the amount of money that went into this. Millions and millions and millions of dollars. This one here will come up again. This is one of the first ones. But here we have all the way to, like, I think, was it this week? They came out at Disney and they've got, like hundreds of tiny robots on the ground that are sensing where your feet are and walking. Well, that's a lot of money. And it means that there's an assumption, we assume that this is the best way to navigate VR. The truth is that many people consider VR primarily to be a gaming medium. And when you look at the most popular games, you'll see that many of them are first or third person shooters. When you look at early VR controllers, they share a design paradigm. They're all designed to support the playing of shooting games because that is perceived as the most lucrative product, right? They're literally gun handles, the controllers. And when you look at the research behind those early walking interfaces, this is from the paper about the original omnidirectional treadmill, and the link is here. But you'll see it directly says, it is the third generation in a series of devices built for this purpose for the US Army's Dismounted Infantry Training Program. In other words, these walking-based interfaces are the best interfaces for some things, but probably not for the most important things that VR can do. One-to-one walking should not be considered the gold standard for locomotion in VR. It is that way not because it is the best form of locomotion. It's that way because it's the most funded form of locomotion. And that really makes a difference when we're thinking about how we would innovate or interact with the space. It means that everybody else is operating on the assumption that this is the best. And the truth is that it's not. One-to-one walking actually has a ton of limitations. I'm going to try and move so fast, it'll be lightning. Okay. One is safety. Here's one of the first VR installations in a museum. You'll notice the handrail around it to keep people from falling down. This is the artist who made the piece behind it, Park MacArthur. She wouldn't have been able to experience that piece as it was designed. Affordability. Look at how much space is required for free walking places. When you think about practicality, you can't fit all of these people roaming around in VR. You would have to sit to fit people in. And the other thing is accessibility. I'm not going to read this whole quote because there's not time, but it's actually from the conclusion of the paper where they built that, the first walking interface. And basically it says, this is maybe dangerous and problematic. If it's off a little bit, people will have a bad time, which means many walking-based interfaces may not be safe or accessible, even for those that can walk. This is not even going to happen. I had a bunch of use cases. The point is, to summarize before they give me the cane, when we compare the kinds of experiences that we can do with these different types of interfaces, walking interfaces are useful. No one's saying that they're a bad idea. They're just not the best one. And they're also not the most accessible. The other thing with this idea of the walking-based interfaces being the best, why is that a problem? Because you look at the many, many, many millions of dollars that have gone into perfecting it, when at a much smaller cost and in a much easier way, you could create a wheelchair-based interface that did just as much, if not better, than the walking-based interfaces that are so well funded. Time.
We have one question for you from online, Justin. Were the maze walls displayed in the XR space during the simulations? Was the display augmented or completely virtual?
It was a completely virtual experience. They were using the HP Omnicept headset. And so the way that we set it up was the target would appear. And then after they saw where the target was, the maze would rise up out of the ground.
Gotcha. Well, thanks so much. I think that is unfortunately all the time we've got. Definitely encourage folks to catch up with Justin afterwards, and it's an amazing thing because I know I for one have heard very little about wheelchairs in virtual reality, and that's something that is a crying shame because it really is the way a lot of people get around.
Just as a final thought, that we didn't realize we were we assumed other people had tested this. Oh, I'm so sorry. And we were like the first, and it's like in the 2020s, and you're looking at the walking interface was built in 1979. So that's a lot of time not spent looking at a place that could help a lot of people.
Absolutely. Well, thanks so much. Hand for Justin, everybody.